Good morning, everyone, and welcome back to theCUBE's live coverage of the Red Hat Summit Ansible Fest 2025 here at the Boston Convention Center. I'm your host, Rebecca Knight, alongside my co-host and analyst, Rob Strechay. Rob, we are both fresh from the main stage where there were lots of Red Hatters, and it felt almost visionary. You know, it was really inspiring. Obviously, lots of new cool product announcements and stuff that you usually see, but it was really cool.
I think why I love open source and I love Red Hat and how Red Hat brings open source to customers is the fact that it does help people understand why certain pieces of open source are really important. And I think, to me, that's why these sessions are super critical.
Exactly. And with that, I would like to introduce our next guest. We have Joe Fernandes, Vice President and GM, AI Business Unit at Red Hat. Thank you so much for coming on theCUBE, Joe. And welcoming back Brian Stevens, Senior Vice President and AI Chief Technology Officer here at Red Hat. Thank you so much. So, Brian, I'm going to start with you and actually ask you one of these big visionary questions. What is Red Hat's vision for the future of AI?
It's a big one. Really, like parallel with Linux.
Yeah.
You know, to be honest, like the way AI is heading is it's a very fragmented kind of world. Every model is coming out. Amazing open source models are coming out, but they're coming out with infrastructure and how to run them. And then every GPU or hardware accelerator, and there's actually lots of them. I know we don't know about all of them. We know about one big one, but they too also often bring their own kind of stack on how to use them. And so, like, our vision's really been like, how do we unify that into a common platform like we did with Linux, where there could be one core, in this case it's a project called VLM, that can run all models and run all accelerators. And then in so doing, think about what that means to like end users. If they're not like DIYing everything that they want to do, where they can just have a one VLM platform and get to use all the best and future models and all the accelerators seamlessly. So it's kind of going back to the old days of what we did with Linux, but we think it really matters right here for AI as well.
Yeah, and I think, to me, one of the keys around that is, and again, you know, Kubernetes is now 11 years old, or almost 11 years old, and Linux, you're on, you know, RHEL 10 now, and it's been around for a long time. I cut my teeth on Unix and then Linux as an admin way back in the day, so makes me feel old. But anyway, when you start to look at what's going on, Joe, we're really in the platform, because I think a big factor for things like Kubernetes and like Linux has always been just the intimidation factor with it, and especially with AI. And I think some of the stuff was talked about on the main stage today, and what's coming in RHEL 10 and what's coming in OpenShift around AI seems to help kind of make it less intimidating. Kind of give us, you know, a view of what was announced and what's really been packaged together.
Yeah, so I mean, Red Hat's always been a platform company. Like, as Brian mentioned, 20 plus years ago, it was bringing x86 and Linux together to power enterprise applications, right? And we brought that to the enterprise. Then with OpenShift and Kubernetes, it was containerized applications and cloud-native application architectures, right? And enabling that across a hybrid cloud environment, because those apps needed to run not just in the data center, but across all the major public clouds out at the edge. That's really powered the OpenShift business and the growth in Kubernetes and the cloud-native ecosystem. I think AI is just that's next evolution, right? And so as a platform provider, we need to enable customers to run their AI models across, you know, any environment, any accelerator, and really any model they choose to power their business. And again, it's new. Things that are new are scary. I remind customers that, you know, 10 years ago, containers and cloud native were new. But now if you're building a new application and you're not building it on a cloud native and containerized architecture, you're sort of out of the mainstream, right? So now the new application architecture is agents, right? But I think agents, you know, 3 to 5 years, it's just going to be how applications are built. Like, they're going to infuse inference, they're going to infuse tool calling, and they're still going to run on this Linux distributed environment that kind of like goes back at Red Hat, like to the beginnings of the company and so forth. So we're really excited about that.
Yeah, and there was some announcements around the inference server and things like that, which to me is also a big piece of bringing things together as part of what Red Hat does, because it's a lot of different pieces that Red Hat had separated out previously, plus things like MCP, which I know that people are still trying to wrap their heads around. They have brought it to open source, and Now it's, kind of how the models talk to other tooling and things like that. Help people understand what, Red Hat's inference server and how that really helps.
Yeah, I mean, the inference server that I was saying before, like, is kind of the core. It's the equivalent of Linux, if you will, right? And Red Hat AI Inference Server being our chosen name.
Yeah.
VLM being, the open source project equivalent to Linux kernel. So it really is that glue layer. It's the thing that, can stay the same so that all the innovation and accelerators and models can reach users without change. And like that, like Joe talked a lot about the platform, but that is the platform. That is the basis of the platform. And what's amazing about it is once you kind of get that part out of the way, then all the, can you imagine the churn for anybody trying to consume all this if everything changes every time they want to adopt something? It's throw all that out. You put people in a position where they have to make bets, and nobody should be making bets. So I think what we've done with VLM, Red Hat AI Inference Server, can be that core platform, and then all the stuff that we've talked about, the right agents, MCP, right. All that stuff is the stuff that runs on top.
Yeah.
Right. And that's gonna evolve because we weren't even talking about MCP, 3 months ago. We weren't talking about agents 9 months ago. So I lay awake saying, like, we definitely haven't figured it all out on top of the platform.
Yeah.
Like, that's gonna innovate, evolve, but luckily the platform stays there, and it's the thing that can kind of enable all of that to happen.
Yeah. I think it was Google, was saying on stage, it's the year of inference, right? And we really agree with that, right? Because inference is about bringing these models to production with productive use cases, right? And VLM is that open source standard inference server that abstracts those models from the infrastructure on which it runs. Again, a hybrid environment at the accelerator level, not just at like the public cloud on-premise edge level. And then agents are just a use case for inference. Like, an agent is an application that infuses inference and, large language models into that application to provide it more intelligence, right? And then you realize the model can't do everything, so it needs to also call out the tools. That's where sort of MCP fits in. But to Brian's point, we talked about what we're doing with MCP and also bringing Llama Stack. There's a lot more that's going to happen or that is happening in the open source community. So you'll see that top layer of the platform continue to grow and evolve as we start seeing those applications and those agents, come to fruition. So,
And how does it make AI run more efficiently? What is the key?
Yeah, so a couple of things, and I'll let Brian explain that. So first, just the inference server itself, right? That's the engine that's running the models. So like the inference server needs to be efficient in terms of how it processes the model requests and sort of distributes that. And then, Brian, I talk about Brian and Neural Magic brought also a lot of expertise in model compression, and maybe you want to talk about that.
Like the inference servers, that's not a new thing, right? Like models, we've been doing models forever, right? Predictive models and natural language processing. People were summarizing documents, so they always had an inference server, but they were different back then. I know back then sounds so stupid. So it's been 2 years, 3 years, right? But a lot's changed, but the way the inference servers could be simpler, because when you did an inference request, you typically just, gave it one document, or you gave it 100 documents, and they actually gave you the results back by just doing one sweep through the model. So one process cycle through the model, and you always knew, whoever's using it, exactly how long that would take. So now it's a new world where all of a sudden the inference requests are turning into generative applications. So guess what? Like the input that's coming into the inference can be small because we just had a question, or it could be massive because you fed it all these documents. And then the generation, which is the output, that can be, you could say you just want, a one-sentence summary, or you could say you want it to write you a physics paper. So the inputs and outputs are completely different. And then moreover, on top of that, the inference server itself, instead of just doing that one sweep, is going around and around. It does a lap every time you're doing a token. So it's gotten crazy, complex in terms of like juggling all these incoming requests. You're packing those together, feeding it into the GPUs to do all the math operations, presenting an OpenAI compatible inference layer in front because everybody wants compatibility.
Right.
So it's really turned into like, as an old Unix person, right? I didn't call you old, I'm old. But as a Unix person myself that was building the stuff you had to manage, like that was what an OS did. There was all these complex algorithms, and for the first time, they have to go inside of an inference server itself. So the the efficiency side is all of that stuff put together on how do you make it efficient? Because like I was saying, GPUs have a really small amount of memory. And that amount of memory actually dictates how many requests you could handle simultaneously. So if you had twice the memory, you could have them twice the requests, so your throughput goes up, but you don't. So you got to like really be efficient on the memory, and then you have to be really efficient on how you actually program the GPUs and the accelerators and how you feed them. But all this software stuff, we had VLM was already being used by a lot of people because it was easy to use. And I think we've 4 to 5x the performance on it in just like the last year. So it just shows you, and there's still that much more work that can probably be done.
And this, just building off of that, this is where the LLMD stuff comes in as well, right? Because how you use the KV cache and things of that nature.
I love that you're watching. Exactly.
I pay attention.
I know. It's so hard to distill it down, right? Like even for myself, honestly. But think about it like this way. So everything we just talked about was one server. And servers come with 1 to 8 GPUs or accelerators attached to them. So that's kind of the VLM, lots of requests coming in, lots of accelerators underneath it. But that's one server. But what we've learned is that if you're coming into enterprise IT, and they're not going to run one server, right? And they're not going to have one, inference workload. They're going to have lots of inference workloads. So the question is, how do you orchestrate that? Like we did with Kubernetes and apps. How do you orchestrate now LLM serving across a cluster? So that's one part. We chose Kubernetes with the LMD project. We said, let's not teach IT something else. They already know Kubernetes. Let's get LMs in the Kubernetes world. But the second part is the more complex part. The second part was around, it's all about meeting the service level objectives of the individual users. Because developers, right, are going to get a little bit of quota. They don't need quite, the response time. But then you're going to have production serving that's going to maybe scale more, and it has to have a certain response time. So all those running on the same cluster, LMD, by doing this thing called disaggregation, it moves away, it separates the processing of all that input for the first token from the processing of those next tokens, which can be quick. And in so doing, it can meet varying SLOs that end users have, all the while driving, more tokens per unit of infrastructure.
Yeah. And 10 years ago, we were here talking about our Kubernetes launch, right? It's very parallel, right? Like Docker was the hot project. Docker innovated how you packaged for Linux container technology, like packaged applications for Linux, which we've been working on for many years. But ultimately, it was Kubernetes. And how do you take a bunch of containers and run them at scale? Because an enterprise application doesn't all run in one container, right? And the load and capacity that's needed to power those applications in production, you need to distribute many containers across a cluster, right? So that relationship between Docker and Kubernetes, kind of very similar to VLM is a single inference server. How are we going to run that at scale for these large scales? And that's what LLMD adds. So it's I think a really big project, and I think we'll look back on this launch as being sort of a pivotal moment and sort of evolving to at scale production deployments. So
along with that, Red Hat's vision is any model, any accelerator, any cloud. So elevator pitch, how do the new products and community that were announced today help customers achieve this goal?
Yeah, so on the product side, we've made a few announcements. So any model, right? I think Brian mentioned this or Chris mentioned this 2 years ago, there was no open source Gen AI models, right? It was sort of a OpenAI versus Google kind of world. And then with the launch of Meta and Mistral, and you've seen just a bunch of state-of-the-art open source AI models released over the past 2 years. And that's great for customers, gives customers choices. So we've announced a validated model program for Red Hat AI to give customers confidence that, hey, we've tested these models, the latest versions of these models, we've matched them up with the versions of our platform, we're providing data and so forth. So that's on the model side. But then, where are you going to run those models, right? You need to run them on GPUs, right? Accelerated hardware. So again, NVIDIA is the gorilla of the space. We need to run great on NVIDIA, and VLM helps us do that. But, you heard from AMD today, you heard from Intel today, you heard from Google, who's building out TPU accelerators, AWS with Inferentia and Trainium, right? And IBM with Spire, right? So a lot of companies are seeing this inference opportunity on the hardware side and trying to be part of that. Again, as part of being a hybrid provider, we need to do that. And then any cloud is just like what we were saying for applications over the last 10 years. Not every model is going to run on Azure or on Google, right? They're going to run across all the clouds in the data center, and even generative AI out at the edge. So, kind of extending that hybrid cloud vision that we've been talking about for the past 10 years now into hybrid AI. That's really what that sort of means for us. And there's a lot more products and capabilities that go with that, but that's sort of in a nutshell, like what it means to us.
Yeah, one thing they noted in that was, he talked about like VLM running on NVIDIA. Like, let's face it, you walk into a data center today and it's NVIDIA dominated because they produce amazing accelerators. And of course, they have their own stack, their own, which they should, and they're the best at it because they've had so many years of experience. What's kind of stunning to me is the vision of how do we get any model to any accelerator. That was why we needed a new open source project called VLM. But being that it's actually 22 months old, I think right now, it's not good enough that if it's like, okay, NVIDIA used their stack, and then for all the other accelerators, we use this other thing. It's kind of a toy. It's not as good enough to be on NVIDIA. But that's actually not what's happening. In 22 months, VLM, even on NVIDIA, is being chosen in one part just because it's just had the luck of being born later.
Yeah.
Right? So in the Hugging Face world, it just did. So it kind of runs those models in Hugging Face where all the models are natively and seamlessly, so there's no extra work, which they kind of have on their inference server, just because they predated it. And then second, it used to be that, you got the usability, but it wasn't as performant. And now it's every bit as performant as the NVIDIA stack. So it's really emerged as, the de facto way, even on NVIDIA. So even if a shop is just an NVIDIA shop, it's a really compelling, easy to use story. And NVIDIA will say this themselves, is that because of that relationship that we have in the VLM community and Red Hat with all those model providers, we get access to those models earlier, as do other people on the server. But we can implement support inside of VLM quicker. So when Gemma came out, when Mistrals came out, when Llamas came out, they don't give us much time. They give us, like I was saying, 2 days to 2 weeks. But we get it done, and NVIDIA's even publicly stated that the best way they can bring new models to their users is actually using VLM themselves. So that's a huge testament. That's a good thing. Yeah. It's a huge testament to like converging, right, and combining our joint innovation together on a same unified project. And I think that's how we're not competing with anybody any longer on that vision, right? We may get to claim the vision, but it's but it's a common project now that very much has invited everybody else.
Absolutely.
Yeah, I think one other thing I kind of last question, because you had Ricardo up from Meta talking about Llama Stack.
Yeah.
When I talk about Llama Stack, people get confused between the Llama models and Llama Stack. How does Llama Stack, from a Red Hat and what you're using it for, help people get to agentic systems faster? Yeah. What are the building blocks that really helps?
So as you know, Meta's like known for their Llama models, right? And that really unlocked a lot of open source generative AI innovation and made people believe that like open source can really compete in this space. So a lot of credit to them, including now the latest release of Llama 4. But what we need to do is also then be able to leverage those models to build applications and agents, right? And so we have capabilities like inference, like RAG, like tool calls, guardrails. We were looking for an API to string that together for the end users. So the end user would be your data scientists and your developers that are leveraging the platform to build their applications and agents. So we had the decision, do we just build our own API or do we use something that's out there? Meta had just released Llama Stack as part of, I think, the Llama 3.3 launch. We liked what we saw there. And, as I think Brian made this point, open source isn't just about a license, it's about a community, right? So it was open source license, but that gave us the opportunity to work with Meta and other partners who had similar interests, right? And that's really what it is. So it's going to become the core API for end users who want to build agents and applications on the platform. Now, they could still just use the VLM and the inference API. If that's all they need and they already have agents, they can bring those to our platform. But as they build new agents, it'll bring new capabilities and also integrate with other capabilities. Like we talked about the Model Context Protocol, MCP from Anthropic. That's already integrated into the Llama Stack Agents API for tool calling. And there's more to come. We're working with Google on their agent-to-agent protocol stuff, and there'll be a lot more projects. If you think about what the cloud-native ecosystem looked like 10 years ago versus what the CNCF community looks like today, that same dynamic is going to happen here. So, we're really excited to work with Llama Stack in the Llama Stack project with Meta and others, in MCP with Anthropic and others, with Google, and there'll be more involvement like that, engagement like that in the community as we sort of move along. So,
Love it.
yeah.
The future is bright. Joe, Brian, thank you so much for coming on theCUBE. A really fun and interesting conversation.
Great. Yeah, thank you.
So much for having us.
I'm Rebecca Knight for Rob Strechay. Stay tuned for more of theCUBE's live coverage of the Red Hat Summit. You're watching theCUBE, the leader in enterprise tech news and analysis.